Today's snapshot topic is scaling your HCP Vault cluster with performance replication. So I'll run through the agenda for today first before we dive deeper into the topic. First, we will start with an introduction to Vault and HCP Vault, just a quick one for those who are not too familiar. Then I'll walk you through some challenges you might face if you are running a single Vault cluster in a single region. And I will then talk about how performance replication looks to overcome some of those challenges. And then I'll show that to you in a demo before we wrap up with some supporting documentation at the end. So a quick introduction to Vault. Vault is actually a security solution by HashiCorp. It's mainly for securing access to your secrets. And secrets could be anything from like API keys, passwords, or certificates even, right? And we want to avoid storing these long-lived secrets as plain text in your source code. So what Vault aims to do is to deliver these secrets just in time with, they are short-lived, so they have a time to live on it, to your applications as they need them. And these secrets could be things like short-lived IAM access keys, database credentials, or even Kubernetes service accounts, and many more. Vault can also act as a PKI root or an intermediate CA. So what that means is Vault will help to automate the creation, revocation, and the managing of certificates all through the Vault API. And finally, Vault can also manage your encryption keys. So maybe you're running multi-cloud KMS keys. So Vault can help to manage the lifecycle of those. It can also be a KMIP server or a software security module. And Vault can also do encryption as a service. So it'll handle cryptographic operations using the transit and transform secrets engines. And Vault is delivered in two flavors. You can either have it fully managed. So on the HashiCorp Cloud Platform, that means HashiCorp SREs will take care of the deployment, management, patching, and upgrading of your Vault clusters for you. Or you can choose to manage it yourself, your own Vault cluster. So that gives you the flexibility, but of course that means you have to manage all the operational overhead that comes with it. So today we're focusing on HCP Vault. And what are some challenges faced if you only spin up a single HCP Vault cluster in a single region? Firstly, perhaps you are running global workloads. So you have workloads that are geographically dispersed, and they might face latency issues if they have to traverse across the globe just to retrieve maybe some secrets from your Vault cluster. Or perhaps you have data residency requirements where due to compliance, you have data that cannot leave a certain geographical region. GDPR is one such example for the Europe region. Or maybe in your organization, there are various teams using Vault, and each team is managing their own Vault cluster. So you might find that they are all working in silos, and there is no visibility into how all your Vault clusters are being managed. That is when Vault's performance replication feature looks to solve all of these things. When we talk about Vault replication, there's actually two kinds. There is disaster recovery and performance replication. So today we're only focusing on performance replication, which means you have two or more Vault clusters, and they follow this leader-follower model where the primary cluster acts as a system of record, and it will asynchronously replicate all of your underlying configuration to the secondary clusters. So the underlying configuration may include things like your secrets engines, your auth methods, and your policies. And your secondary clusters will be located in different geographical regions so that your workloads that are hosted closer to that Vault cluster only needs to communicate with the cluster that's closest to it. So that firstly reduces latency, and secondly, with the next feature we'll talk about, that will help with data residency requirements. So as part of performance replication, you will also have a feature called path filters. So path filters will allow you to specify which secrets ought to remain local to the cluster and not be shared across clusters. So as an example, here in our primary cluster, we have a secret that is shared with all of its secondaries. But sometimes we have seen use cases where there are certain secrets that need to remain local and should not be shared across clusters and should only remain in its own cluster. So you can use path filters to mark these secrets as local. So just to recap or give an overview of the differences between a performance replication and disaster recovery replication. Firstly is that DR will mirror the full configuration of the primary cluster, including all of its backends like auth methods and secrets engines. For performance replication, it will also mirror the primary cluster, but it may not mirror all of its backends depending on what path filters you enable. And also for performance replication, it will not mirror the tokens and leases. Those will remain local to its own cluster. And finally is that performance replication clusters can handle all client requests. So any reads or writes can be handled by it, whereas a disaster recovery, the DR cluster, will not serve requests until it is promoted to be a new primary in the event of a DR. So let me just set out the scenario for you before we dive into the demo. Imagine you are a company that is headquartered in Singapore and you have operations in Australia as well. So you have applications running both workloads in Singapore and maybe some replicas in Australia. However, you find that there is some network latency issues with the applications in Australia if they were to communicate with the Singapore cluster. So what we can do here is to spin up a secondary Vault cluster, performance secondary, in the Sydney region so that your applications in Australia can make API calls directly to the Sydney Vault cluster. And what that also gives you is locally hosted secrets. So Singapore secrets only remain in the Singapore Vault cluster, whereas the secrets in Australia only remain in the Sydney cluster. So I'm going to list out some of the namespaces and secrets engines that I'll show you in the demo. Some of them are shared across Singapore and Sydney, whereas some of them will remain local. So firstly, with every HCP Vault cluster that you deploy, it remains in the admin namespace. Admin namespace is analogous to the root namespace if you were to spin up your own Vault cluster. So there is a Singapore namespace under that, and we will mark it as local with the path filter, so it will not be replicated to the secondary. And we also have a shared namespace called APJ. So in this APJ namespace, we are mounting a few secret engines. One of them is the APJ keys, which will be replicated and will be found in both Singapore and Sydney. We also have the database secret engine called shared database, also shared amongst both clusters. However, we will see that Singapore keys, the KV secrets engine that is mounted at Singapore keys will only be in the Singapore cluster, whereas the Sydney keys mount will only be in the Sydney cluster. Okay, let's see how we can enable that path filters and replication across both clusters. So firstly, when you log into your HCP portal, and you will see a list of your Vault clusters. Right? I have a primary Vault cluster here and a secondary performance replication cluster. So how to enable this PR feature is in your primary cluster, you can click on replication at the side. And then over here, if you don't have one yet, you can create a secondary PR cluster. So you can see that my primary cluster is running in AP Southeast 1, which is Singapore. And my secondary cluster is running AP Southeast 2, which is Sydney. When I click on the three dots at the side here, I can choose to edit path filters. And this is where I will specify the paths, the mount paths for both namespaces and your secrets that I do not want to be copied over from the primary to the secondary cluster. So let's look at the first one, the Singapore namespace. In my second tab here, this is my primary Vault cluster. You can see that I have two namespaces, APJ and Singapore. And in my third tab here, it's just APJ. So the Singapore namespace is not found here. So even though it's listed here, when I try to access it in my secondary cluster, I actually have no way to access it because it's not copied over to this cluster. Let's have a look at the APJ namespace in both clusters. So the second path filter that we enable is called Singapore keys. So what this enables is the Singapore keys mount can only be found in the Singapore cluster, and in the secondary cluster, you only find the Sydney keys mount because I have mounted it as a local secrets engine. Let's have a look at some of the shared mounts as well. So in APJ keys, which is found in both clusters, you can see that they are in sync, where you can find AWS keys and Azure keys there. If in my primary cluster, I were to create a new secret at this mount, maybe I'll call it demo snapshot with a key value pair. When I save this, and in my secondary cluster, I'll do a refresh, I can see that I will now find the new KV pair here. And I can even do a write to the secondary cluster. I'll create a new version of this. And if I save it, I will find version 2 in the primary cluster as well. So this shows that in both your primary and your secondary clusters, you can do read and write requests to both clusters, and they will remain in sync. You can also see the shared database is found in the primary cluster and in your secondary cluster. So depending on your use case, maybe applications in both regions are sharing the same database, in which case you can share the same database secrets engine here with the same configuration to your same shared database. So that's a pretty simple demo just to show you how you can set up performance replication, as well as path filters and local mounts to keep data local to where it should be. Now, as a wrap up, we have seen that performance replication feature is very easy to set up with HCP Vault. It's just a few clicks in the UI and you're able to spin up a new secondary cluster and then determine which namespaces and secrets engines you want found there. So I'll leave you with this set of slides at the end. Eric will send it over with the recording. Here you can find some of the documentation and learn guides if you want to go through tutorials to set up your own performance replication. It's a step-by-step guide here, which is fairly simple to follow. And that concludes my snapshot. Thank you, everyone.